So on to these guys. So last day when we were talking about quadratic expressions, we talked about the general quadratic, we talked about another type of quadratic and another type of quadratic. Anybody can recall the types of quadratics we talked about last day? Okay, you pipe down. Alright, so back to this. So yes, one is a perfect square, one is a difference of two squares. So can anybody here identify one of the expressions which we can associate with this difference of two squares? Lovely, this one. So this is our difference of two squares, x squared minus 169. We have two square terms, find the difference of it. Now the perfect square. Anybody could remember what I was talking about? There's a particular way you can identify a perfect square, right? And sometimes you don't realize it's a perfect square until you do complete factorization. But for those of us who probably could recall how to identify a perfect square without factorizing it first, share with us if you remember anything. Silencio. Okay. So this is, oops, wrong one. I like to make a wrong connection. This one is my difference of two squares. And although you can't see it just yet, this one is the perfect square. Alright? And here's how we identify a perfect square. Okay? If you're able to notice that this is a squared term, 64 is also a perfect square and a squared term, 8 squared. And then 16. Think of some products that could give you 16 utilizing 8, well 2, 8, and 1. You'll notice this. 16 can be written as 2 by 8. And the reason why I said 1, because over here, x squared, this is 1x squared. So this could be written as 2 by 8 by 1x. Just a second, Mr. Jaden says, yes, 8 by 2, lovely. Alright, so your perfect square will always be a squared term at the beginning, squared term at the end, and the middle term will be 2 times the product of the square root of the first term and the square root of the second. And like I was saying last day, okay, you don't have to remember how to identify it. For some people, you might be able to recall this, you might be able to understand it, but otherwise you'll be able to just factorize things completely, right? And noise. Okay. So like I was saying, you will still be able to do the factorization regardless of being able to recognize a perfect square. Once you know how to do factorization of quadratics, you'll be able to factorize absolutely any quadratic expression, alright? But it's still good to know what a perfect square looks like, what a difference of two squares looks like, and what a regular quadratic will look like. So that way, for people who might be able to identify these two in particular, the difference of two squares and the perfect square, you might be able to more readily factorize it. So from here now, let's talk about doing some factorization. So erase these arrows. Okay, who would like to factorize the first one for me? So although we talk about it being a perfect square, I'd like to do the factorization technique that we learned about. So who would like to start that off for me? How do we factorize a quadratic? X. Okay. X. Yes? Okay. Like I was saying, the technique you remember there's a technique that we learned for factorization of quadratics, general quadratics. That technique, you could apply it to this, you could apply it to this, you can apply it to this, right? All types of quadratics you'll be able to use the technique on. But with the perfect square difference of two squares, like I was saying, recognition of the form would make it easier for some of us, that we'd be able to go instantly from quadratic expression to completely factorized binomial product. Alright, so the technique though, the general technique, anybody remembers the general technique? Lovely, yes, let's start off there. So let's find the coefficient. So we're looking at question 3. Alright, I see you, Kyla. Okay, so question 3, we want to find the coefficients. You'll remember, what do we label the coefficients as, and where are the coefficients and the constant, etc. Let's see what Nadira has to say. Yes, A, B, and C. Let's go. So, we want to identify A, B, and C. Anybody want to tell me what is A, what is B, what is C? Lovely. So A is 1 because the coefficient of x squared is 1. Alright. Lovely. And don't forget our signs. Those signs come in really, really significant in the process, right? So B is 16, and like I was highlighting here, B is the coefficient of x, and the sign is also going to be important, right? So although I just write 16, I understand it to be a positive 16, positive 1. Alright, lastly, our constant, definitely going to be this, C. Alright, so lovely work. Thank you very much for identifying A, B, and, by elimination process, we get C. So thank you, Aliyah. So let's continue from here now. We've identified our constant and our two coefficients. Can anybody tell me, what do we do from here? Lovely, let's go. A by C. So we find the product of A and C, and A by C is 1 by 64, so we get a positive 64. Alright? Okay, what next? Yeah, you go ahead. So we know we have to do some sort of multiplication, some sort of product. Alright? So you could help her out. She lost her train of thought, but you can help her out. What do we need to do? After we get AC, lovely. There we go, just 16, right? So we want a product. Lovely, Jaden. So we want a product that's going to give us 64, but when we find the sum of those two factors that we've chosen, it's going to give us a positive 16. And I like that she put in sum or difference of those two factors, because at some time in doing questions, you'll have some different signs, and you'll notice it there, right? And that will also influence the way in which you choose your factors. So in this case, because everybody is all perfectly positive, we can simply look at the numbers, and like Jaden just dropped in the chat, 64 is the product of 8 by itself, 8 by 8. And if you were to add 8 and 8, you get 16. Alright, so now that we have that, alright, we have our pair of factors. The pair of factors we choose can in fact break up nicely and give us back the 16 when we add it together. What do we do now? Lovely. So remember earlier when we were looking at the quadratic where we use the factorization by grouping, this is what you would have done before you had gotten that particular expression. You'd break up, or you'd decompose your middle term into the sum of x terms where these are the new coefficients, because this is what allows us to utilize that factorization by grouping in here so that we can factorize this quadratic completely without using a trial and error method. Alright, because back in my time, don't mean to sound old, back in my time, my teacher taught me how to do factorization of quadratics by doing trial and error, where you basically have to sit down and kind of play around with factors until you kind of figure out which ones go in the brackets. So now that we have like a process to help, it makes it a little bit more, I would say, sort of foolproof for people who would have trouble with like identifying factors and things. So from here now that we broke it up, what do we do from here? Lovely. We're going to apply the grouping method. So anybody wants to tell me what we're going to do? So we did look at the grouping method, so you all can just tell me what I'm factorizing and what are those factorized forms. Mm-hmm. Mm-hmm. Lovely. So you're going to do x, Lovely. So completely factorized form of the first part, x into x plus 8. What next? Mm-hmm. Right. Lovely. So you're going to factor out a positive 8 here. Lovely. Alright. So look at this one. You'll notice that we have x plus 8, and then you still see an x plus 8. So this is something that you'll notice with a perfect square. When you're doing this particular technique, you're just going to notice like you have the same terms all over the place. Alright? Then from here now, what are you doing? Alright, so these guys, so you're going to put together, Right. And what do you all notice about the completely factorized form? Look at it. There you go. Both your binomials are the same. And in the case where you have two binomials that are the same, this is why we call it a perfect square, because we can write it as this now. We're multiplying a binomial by itself. So we put x plus 8 squared. Alright, just give me a second, Renal. So Renal, yes, that's it, Renal. Alright, to the power of 2. So this is our completely factorized form for a perfect square. And like I was saying, for people who would have been able to recognize it as a perfect square from the beginning, a sort of shortcut way would be something like this. So if you notice, is x squared plus 2 times 8 by x plus the 8 squared. Then from here now, you'd say, well, okay, this completely factorized form would be the square root of the first term, square root of the second term. And both your binomials would look like that, because it's a perfect square. And again, because it's a perfect square, you can write it like that. Alright? So, as I mentioned before, for people who could recall this, you all might be able to do the complete factorization immediately. And for people who can't remember that, or you might find it confusing, it's okay, work with this. You will still get the answer. Alright? So we looked at how we factorize completely a perfect square with this particular question.